Okay, now we have just one more use of our rational expressions, polynomial rational expressions, and we're going to put them into what is called complex fractions. So this is the fifth one that we're doing. We started with simplifying the polynomial rational expressions, then we went to multiplication, then we went to division, and then we went to addition and subtraction in one part of the lesson, and the last part is doing the complex fractions. And remember, a complex fraction is a fraction over another fraction, or a fraction expression over another fraction expression. So let's do one of these first as a simple one that we can do. So if I have 2/3 over 4/9. There's two ways I can do this. The first way is to simply take and rewrite this as 2/3 divided by 4/9, and then do we keep change flip 2/3 times 9/4. Look for those common factors. 9 divided by 3 is 3. 4 divided by 2 is 2, and that gives me 3 times 1 is 3, and 2 times 1 is 2. So it simplifies to 3/2. That's one method. The other method would be to multiply my numerator and my denominator by the lowest common multiple, or the lowest common denominator, which in this case 3 and 9. My lowest common denominator is 9. And because I'm doing the same to the numerator and the denominator, that equals 1, so I can do that. Now simplify this fraction. 9 divided by 3 is 3, and 3 times 2 is 6. And see, it eliminates that fraction in the numerator. 9 divided by 9 is 1, and 1 times 4 is 4. And all I have to do now is simplify my fraction. I end up with 3/2. So either method, you get the exact same thing. So let's do some of them. First of all, with method 1 that are more complex. So let's write down the series of steps or processes or principles, whatever you want to call it, that we are going to use. So your first step is to simplify the numerator and the denominator into one fraction. Number 2, rewrite the complex fraction as two fractions with a division between. Use keep change flip to change to multiplication. And 4, factor if you can. Factor or simplify would be the best way to say it. Simplify or factor, then simplify. Okay? So, let's look at ones that are more difficult. These first we're going to do with this method, okay? So, we have x plus 1 over x, and this whole thing is over x minus 1 over 2x. Rewrite this as my first fraction, my numerator fraction, x plus 1 over x, divided by the denominator fraction, x minus 1 over 2x. Now, keep, change, and flip x plus 1 over x times 2x over x minus 1. Now, we are ready to do our process to be able to simplify this. So what's it going to be? Well, x and x cancel, leaving me 2 times x plus 1 over x minus 1. And that is finished. So you can see this works really nicely. Now let's look at the other one. Here's another one, okay? 2 plus 1 over y over 3 minus 2 over y. Okay, my first step is to get one fraction. So this is 2, and I have to get it to 1. That means I'm going to have to get a common denominator here by multiplying both top and bottom by y, giving me 2y plus 1 over y. And the same thing here. I have a y in the denominator, so I have to do the same thing here to get my common denominator of y. So this is 3y minus 2 over y. Now, we're ready to rewrite this as a division. So this is 2y plus 1 over y divided by 3y minus 2 over y. Okay? Now, keep, change, and flip. So we will have 2y plus 1 over y times y over 3y minus 2. Simplify by eliminating common factors, and you are left with 2y plus 1 over 3y minus 2. And that does not factor or simplify any more than that. Okay. Now, we're going to do some problems using the second method, okay? So, first of all, let's get down the process of the second method so you know what's going to happen. Okay, number 1, look for the lowest common denominator for both parts of the complex fraction. And it has to be the same for both. Your second step, multiply the numerator and the denominator of the complex by the LCD, the lowest common denominator. And 3, then simplify each part and 4, when that is finished, check for more simplification. Check if anything else can be done. Okay, so let's look at this method. We're going to do the same, one of the same ones we already did. So I have 2 plus 1 over y and 3 minus 1 over y. Now notice, or 2 over y. Put 2 over y. Now notice, I have a y in my denominator here and a y in my denominator there. Therefore, y is your lowest common denominator. So we have found that your LCD is y. So we're going to multiply this times y and this times y. Y times 2 is 2y. Y times 1 over y, the y's cancel, and you're left with plus 1. Y times 3 is 3y. Y times negative 2 over y, the y's cancel, and I'm left with minus 2. And it's already finished. This is why I like this one. It often comes out very quickly. Let's look at another one that is more complex. Again, using this same system that we just did. To p plus 5 over p minus 1. All of that is over 3p minus 2 over p. As you see, this one is quite a bit more complex. Why? Because I have different denominators. So to get my lowest common denominator on this one, we're going to have p times p minus 1. So that is what we will multiply here. P times p minus 1 and p times p minus 1. So here I have 2p times p minus 1. Okay, so this is why it's more complex. 2p times p minus 1 and plus p and p minus 1 times this one. Your p minus 1's cancel, and I'm left with p times 5, which is 5p. And now the same thing here. I have the same thing, p minus 1 times 3p. So I have 3p times p minus 1. And then here I have 2 over p and a p, so my p's cancel, and I have minus 2 times p minus 1. Okay, now let's simplify this numerator. Well, first of all, 2p times p is p squared, and times p again is 2p cubed. 2p squared times minus 1 is minus 2p squared, and then plus 5p. In my numerator, I have 3p squared times p is 3p cubed. And then I have minus 2 times p is minus 2p. And negative 2 times negative 1 is plus 2. Okay. I can pull a p out of the numerator, but since I cannot pull one out of the denominator, it doesn't do me a bit of good. So therefore, that is as simple as this thing goes, and it doesn't simplify it anymore. Let me check this. 3p squared times p, I skipped one. Okay, so 3p squared is 3p cubed. 3p squared times negative 1 is minus 3p squared. And then negative 2p times p is minus 2p. And negative 2 times negative 1 is plus 2. And I didn't do the same thing up there. Okay. So, again, although I can pull a p out of the numerator, I cannot do the same with the denominator. And therefore, there will not be any common factor. So, that's all we can do. 3p minus 3p squared would be p minus 1. 2, yeah. No, there's nothing else we can do with that. That's as simple as it gets. I don't know if the other method would have been easier or not, but this one is a more complex fraction. And that is the last one of this particular lesson. So as you see, we use our factoring for a lot of different things. Enjoy doing the factoring and take off and have fun with your lesson.